Hey everybody, my name is Tim Bryan. I like to make sports analytics videos. This is part two of the Introduction to Machine Learning video series that I'm doing. Part one was kind of just an overview of basic machine learning concepts through the lens of this NBA rookie longevity data set. So we've got standard NBA statistics here. These are NBA rookies' first year statistics. Things like games played, average rebounds, assists, steals per game. And then our target column is whether or not they're in the league after 5 years. So a one would indicate yes, they are in the league after 5 years, and a zero would indicate that they're not. So this is our training data. We're going to use this to create a model that will predict whether or not the rookie is in the league after 5 years, solely based on their first year stats. So the library we're going to be using today is called PyCaret. It's an extremely powerful library. If you have basic machine learning skills, I shouldn't say skills, basic machine learning ideas on vocab words and things, and you have basic Python skills, you'll be able to use this. But before we get started, if you're installing PyCaret, I recommend you download Anaconda and put PyCaret in a virtual environment. So the way you do that is first download Anaconda, and then you open up your terminal and run this. Create a new virtual environment. I've just called mine PyCaret here, as you can see. But you want to create that virtual environment, and then in the terminal, activate it, and then install PyCaret in there. And the reason you want to do that is because PyCaret has very specific versions of all these dependent libraries like scikit-learn and pandas and basically every Python library you use. It's going to use a specific version that's probably an older version than what you have on your root Python version slash Anaconda environment. So you don't want to mess up all your versions. So that's why you want to do it in its own virtual environment. It can cause a huge headache if you change the version of everything you use on a daily basis. So then when you create a notebook, a Jupyter notebook, make sure you're logged in, you're using the PyCaret kernel that you just made. All right, so here's our data set. Pretty simple and basic NBA statistics. Um, we're also going to use this Pandas Profiling function, and it's again a very powerful, simple tool to use. It gives you a lot of information with just like one line of code. So it'll give us, it'll tell us what if we have any null values. I mentioned in my last video, when you're pre-processing your data, the first thing you should do is handle for null values. We have no null values, so we don't have to worry about that. But it'll also tell us our variable types. We have 21 different numeric columns, and then our categorical column is our target, which is whether or not the rookie's in the league after 5 years. So we can see the distribution of each of our variables, whether there's any outliers. Looks like a pretty normal distribution here. But yeah, this kind of gives us an idea of our variable distribution, the distinct values, things like that. And if we go all the way to the bottom here, we can look at the correlation. This is also pretty interesting. This could give us an idea of perhaps some collinearity if two different variables are influencing each other. So as you can see, the closer it gets to the red color, the more those variables influence each other. So something like 3-point attempts correlates pretty highly with field goal percentage. I wouldn't have guessed that, but these are kind of some interesting, things to consider when you're building your machine learning model. And all it took was a simple, a simple one line of code to profile our entire data set like this. So yeah, take a look at Pandas Profiling. All right, let's get into the machine learning part. So we're going to import PyCaret classification. And again, I explained in my last video, classification is just a type of machine learning problem where we're given features, which in this case are our rookie NBA statistics, field goal percentage, those things. And then we're trying to predict based on those features what the label is. And our label, again, is this rookie in the league after 5 years? So classification problems doesn't have to be binary like that. It doesn't have to be a simple yes or no. But in this case, it is a binary classification problem. All right, so we're going to create a new variable and call the PyCaret function setup, where we're identifying our data, our target column, which just happens to be called target. And then you also have to pass in a session ID, which is just a 3-digit number. So I'll run this. And when you run this, what it's going to do is it's going to ask you if it correctly identified each data type. It does its best to guess what each data type is. And in this case, these are all numeric. And our target column is obviously our label that we're trying to predict. But if it identifies things wrong, you can always adjust it here. So if I hit enter, we can see I haven't adjusted any of the settings, but if you wanted to adjust the settings of this model, you can do so. So there's things like handling for missing values. You can handle for missing values in a number of ways, which the first would be to just leave a 0 for the missing values. The second would be, using the mean value. There's a lot of different options for handling missing values. There's things like you can set the PyCaret tool to look at training on the GPU, which will obviously speed things up. You can normalize your data. Normalization is just, we've got things like 3-point percentage, which obviously that's in a percentage scale out of 100. But we also have things like average steals per game, which is just a raw integer. So machines don't understand what they're looking at least not yet. They just see these values as numbers. So when it sees something out of 100 and then, maybe something like games played, which is a raw number, these can, if they're on different scales, it can throw off the training of the model. So normalization just puts everything on the same scale. This may or may not help the training of the model, but these are examples of things you can adjust in the settings. And you may want to run through the model without adjusting anything in the settings one time, see what the accuracy looks like, and then slowly tweak different settings depending on how that improves the accuracy or whatever metric you're looking at. Speaking of metrics, here we can see that the PyCaret compare models function will run our data set through 10 to 12 different machine learning models. It only takes about 30 seconds, which, like I was saying, that's pretty powerful. So we can see all the different machine learning metrics for each model type. So it looks like logistic regression is our highest performing model in terms of accuracy, at least. You may not always want to optimize for accuracy. Things like recall and precision may be more important. If you don't know what the difference between recall and precision is, recall would be an example of you're casting a wide net of your machine learning model. So you're going to get a lot of false positives. Well, not necessarily, but you're optimizing so that your machine learning model is more likely to predict yes than no. So, then precision is just the opposite. You're optimizing for when the model is identifying something as yes, it is usually right. So I guess an analogy, I have an article here. An analogy would be if you're optimizing for recall, you're casting a wide net. So, if you're fishing, you may catch, a good amount of fish, but you're also going to get a lot of crap in your net. And then precision is you're going to get less fish, but there's going to be like no false positives. So depending on your use case, you may want to optimize for recall versus precision. For example, if you're thinking about training a machine learning model on predicting whether a tumor is cancerous or not, obviously you would want a high recall model there because it's a false positive is better than a false negative, if that makes sense. So anyway, these are the models that our compare models function is spit out. It looks like logistic regression is our best performing model, so we're going to run with that. So once you've identified or picked the model you want to run with, all you got to do is use this create model function, and we're setting it equal to LR. So when you're using this create model function, you can see up here in our compare models table, it'll have a couple letter identifier for each model type. So just make sure you're passing that into the create model function. So it's going to run through the model, roughly 10 times and give us an average of the machine learning statistics here. So then we're going to further tune it. I'll let you guys read into what tuning a model means, but you can see it marginally, I mean, even not really at all, improved the accuracy of the model. And then we can just, kind of evaluate the model using visualizations. Again, each of these is pretty amazing. Just one line of code will spit out this advanced, metric identifier, not identifier, evaluator for our model. So we can see as the model's learning the true positive rate versus the false positive rate for each of our classes. So if these lines were below this 50% line, we would know that our machine learning model is basically just guessing and it doesn't have an understanding. But since it's above the line, its true positive rate is going up as the machine learning model learns. We know that it's actually identifying real patterns in the data and it's not just guessing. So I was talking about precision versus recall earlier. Here we can see precision versus recall in one chart. So as our machine learning model is going through the data, it's getting better and better at recall, and its precision's kind of going down. But this is if you were optimizing for something to have a higher recall or a higher precision, this is a chart you would want to look at. Here is our confusion matrix. So on the x-axis, we can see what our machine learning model predicted. So a 0 would be the machine learning model thinks that this NBA rookie is not going to make it 5 years in the league. And then on the y-axis is the actual class. So 0, 0, this is a true negative. The machine learning model was correct. This rookie is not in the league after 5 years. A 0, 1 is a false negative. The machine learning model says no, but the rookie actually was in the league after 5 years. And then 1, 1, that's the model is predicting yes, and it was a yes, so that's a true positive. A 1, 0 would be a false negative. So this just kind of gives you an idea of where the predictions of the model are lying in terms of reality. And then this is probably what you want to pay attention to the most. This is our feature importance plot. So it's looking at all of the features, which are our NBA statistics, and deciding which of these are the most important. So we can see by far, it looks like turnovers correlate the most to whether or not the rookie is in the league after 5 years. So obviously, a low turnover rate is a good thing. So, we can see that turnovers are important. Other important metrics are things like offensive rebounds, steals, blocks, defensive rebounds, 3 points made. And I guarantee you, if we so the data set starts in 1980, if we had started the data set maybe in 2010 or something, I think 3 points made would be higher on this feature importance list. But but we can see, get an idea of what features we want to optimize the model for. And so yeah, that's the power of PyCaret. The way PyCaret should be used is kind of like what I've done here, just running through very quickly the data and seeing what machine learning model could potentially do. In the next video, we're going to, from scratch, train a machine learning model using probably scikit-learn or PyTorch rather than PyCaret. So it'll be a lot more in-depth, but this just gives us an idea of what could be done in terms of machine learning for this data set. So appreciate everybody watching. If anybody has any questions on installing PyCaret or running different codes, different functions in PyCaret, let me know. I also have a Discord with 15 people in it or something. We just talk about sports analytics and help each other with different coding problems. So I'll leave a link to that if you'd like to join the community. But yeah, appreciate everybody watching. Thank you.